Good morning, everyone. Today we're going to talk about mixtures, types of mixtures, and what would affect the solubility of a mixture. So first we're going to start out with the definition of a mixture. A mixture is defined as a combination of two or more substances. It could be solid with solid, solid with liquid, liquid with gas, or any other combinations. There are many examples for mixtures: cookie, salad, gasoline, salty water, and gold. Now you would ask yourself a question: how gold and gasoline is a mixture? Basically, this introduces us to our next topic: homogeneous and heterogeneous mixtures. First, we're gonna introduce the homogeneous mixture. A homogeneous mixture is a gaseous, liquid, or solid mixture that has a uniform in composition throughout. For example, solid with solid, such as copper and nickel, which is an example of an alloy. A liquid in liquid is an alcohol in water. And gas in gas, for example, is oxygen and nitrogen in the atmosphere. This gives us the relation between the solvent and the solute, which makes up the solution. First, the solvent is the dissolving medium in a solution, and it's mostly water. This is why it's called the universal solvent, and the solute is the substance that dissolves in the solution. Next is the heterogeneous mixture. It's a mixture with non-uniform composition, and at least two of the mixture component must be separated for the mixtures to be heterogeneous, for example the soda and the party mix. And now we're gonna talk about the two main types of heterogeneous mixture, which is the suspension and the colloid. First, we're gonna talk about the suspension. Suspension is a heterogeneous mixture in which the particles in a solvent are so large that they settle out unless the mixture is constantly stirred. This happens because the solute contain particles that is over 1,000 nanometer in diameter that could be seen with a naked eye, as you can see in the example above. And on the other hand, we have colloid, which is also a heterogeneous mixture. A colloid is a heterogeneous mixture that has particles that are intermediate in size between those in a solution and a suspension. It has particles between 1 nanometer to 1,000 nanometer in diameter. They actually look like a solution, however not. In this example, jellies, whipped cream, pumic stone, mist, and milk would look like a solution, but we're gonna know how we're gonna differentiate between a solution and a colloid. And now I will show you the different types of mixtures. First, with the solution, we'll add the sugar to the water. This is the solution now. The colloid is the water. Sorry, is the milk. And the last one is the suspension. So this is an example of a suspension. This is an example of a colloid, and this is example of a solution. Now I'm gonna show you the Tyndall effect, how to recognize the difference between a colloid and a solution. So as you can see, a solution doesn't scatter light, and the light passes through it easily, and here it doesn't, it scatters light. That's the Tyndall effect. Finally, we're gonna talk about the factors that affect the rate of dissolution. First, the surface area. Here are some sugar, that is normal sugar. And here is a sugar cube, one sugar cube. As you can see, mixed. Most of the sugar easily mixed, but here, even if you stir it, it will be hard to mix. As you could see, it takes more time and effort for the sugar to be mixed. first example of the factors, the surface area. Factors that affect the rate of dissolution is the agitating solution. If we add a tablespoon of sugar in both cups, then we still put this one first, more, and then the second one. You can notice that this is easily mixed, and this is not mixed. And the last factor that affect the rate of dissolution is the heat, in which heating a solvent would be easier for the solute particles to spread throughout the solution. And that was the end of our presentation, and thank you for listening.